Okay, welcome back. So friends, we are discussing about the earth atmosphere. In the earth atmosphere, I said there are different layers from the surface. You have the troposphere. This troposphere is the zone of mixing of all gases, I said. It is the zone of mixing of all gases, right? So in the troposphere, the height is more at the equator, at the pole height is less. It is primarily because of more temperature and convectional instability at the equator and sinking of the air, cold air at the poles. So this way, tropopause also, tropopause from the equator to pole, it is inclined. Tropopause is inclined from equator to the pole, right? So this is the cause, this particular part, as I just said, this region has most of the denser gases, including oxygen. You have most of the moisture and dust particles are there. Whenever this moisture come in contact with the dust particle, hot dust particles, they are responsible for, they form like a hygroscopic nuclei. When these dust particles cool down, dust particles generally cool down very quickly as compared to the moisture in the atmosphere. This leads to subsequently what develops in that particular regions. We have development of again hygroscopic nuclei, cooling effect, and subsequent the fall in the temperature. This fall in the temperature may subsequently leads to the formation of dense cloud also, cloud formation, precipitation, all these processes associated with this zone. This is called as the which zone? This is the troposphere. Friends, as I said, this is the zone of life layer. I can say the lower layer is the friction layer, upper layer is the laminar layer. There are two layers of this troposphere itself. We have two zones here. You have here lower layer. This is known as the friction layer. What do you call? Friction layer. Friction layer, and this is the laminar zone, friction layer and laminar. Lower 1 kilometer is the friction layer, where the velocity of the wind generally is very comparatively, velocity of the wind is less because of frictional drag, and so many things are there. There are a lot of things associated with that also, right? So these are certain things. Anyway, almost all atmospheric phenomena, I said, whether it is formation of the cloud, precipitation, subsequent precipitation, atmospheric circulation, whatever is there, everything is associated with this particular zone. This is called as the troposphere. Troposphere, the term came from tropos means mixing, and sphere, zone of mixing of all gases. This is what I did discussed earlier, and let us see now. This height of the troposphere differ, I said, at different zones here. Let me again tell you certain things. The troposphere and the stratosphere. You see here, troposphere is here, troposphere over stratosphere, mesosphere, ionosphere, exosphere. Troposphere and stratosphere, they are here separated by a tropopause, and stratosphere, mesosphere by stratopause. The upper zone of mesosphere, ionosphere, this is transitional zone is mesopause. So pause means stop, where the characteristics of one particular zone stops, that is the pause. So what happened here in this case, there is no change in the temperature, in this particular pause zone. My friends, I told you just earlier, before the break, I said that there is decrease in temperature with increasing height. There is a decrease in temperature, increasing height. Okay, and again temperature will fall here, then again increase, then again fall, then again it will be like this, constant, then again it will be like this. So I said there is a decrease in temperature with increasing this. Here there is increase in temperature, increasing. Here again decrease, here again increase, and here also increase. I said with respect to height there is decrease in temperature. As I told you, this is a lapse rate, this is not constant. My friend, the lapse rate as in some of the book has written 6.4 to 6.5, because with 165 meter of height 1 degree Celsius decrease, 165 meter, on that basis it is like 6.5 nearly approximately. Okay. Why there is a change in the temperature condition? Please note down here. Lapse rate of 6.4 degrees Celsius to 6.5 degrees Celsius per kilometer is due to, lapse rate means decrease in temperature, increasing height. It is due to what? It is due to the following. First one, there is a decrease in the density of air, decrease in the density of air with increasing height, decrease in the density of air with increasing height you have. With increasing height there is decrease in the density of air. So what happened? Due to which, or so, the heat transfer rate is also decreases with height. Heat transfer rate is also decreases with respect to height. Heat exchange rate also decreases with respect to height. And this is the cause, you know, there is a decrease in temperature, one point here. So more the denser the gases, more quick the heat exchange rate. This is also another thing. As you know, more pressure, you know about this. If you look at density is more, temperature will increase. More density, more temperature, more pressure. In that case, in a closed system, if you look at. Now, this is also a cause. Here you have another point. With increasing height, another point is the Earth's atmosphere generally heated up due to terrestrial radiation. The Earth's atmosphere generally heated up due to terrestrial radiation. Okay. And the impact of terrestrial radiation decreases with height, with increasing height. Okay, again I am saying the Earth's atmosphere generally heated up due to the terrestrial radiation, and the impact of terrestrial radiation decreases with increasing height. So, with increasing height there is a decrease in its impact. So, definitely you will have like low temperature. With height you have less number. Let me draw a diagram and show it to you on this, those who are not getting the thing properly. See here, This is the earth surface. You are getting here sun rays. Sun rays here is sun rays is in terms of what? I said sun rays is, you are getting the sun rays in terms of short wave insolation. But while it go back as long wave terrestrial radiation, long wave terrestrial radiation going back. This is as insolation, this is going as terrestrial radiation from the earth surface. Okay, is the earth here. From the earth it is going back as this is long wave, this is short wave here. So, the impact of this one will be more in the lower atmosphere, definitely. Lower atmosphere impact will be more as compared to the upper part, is not it? The lower atmosphere impact will be more, and this may leads to, this is troposphere. With increasing height, decrease in the temperature will have. Two things I just said. One, I told you about density of gases. Second, I said terrestrial radiation. Okay. Somebody says, sir, may I write lapse rate 6.4 degrees Celsius per 1000 meter? Yes, why not? You can, no problem at all. Okay. So, what is there? Like, I hope you got it. With increasing height, there is a decrease in temperature. This is called as a lapse rate. So, because there is a decrease in temperature, so temperature decreases, so cloud formation is possible. Because of this decrease in temperature, you have precipitation is possible. Okay. Because of decrease in the temperature only, almost all other phenomena is possible. Okay. Here is a question, sir. How does the density of air decreases with increasing height? I told you, because of gravitational attraction or gravitational force field of the earth itself, earth gravity. So, those who are denser one at the lower part. So, with increasing height, density of air decreases, particles may be cold. Because why they are cold? Because the particles go away from each other, gap हो जाएगा ना, particles distance will be more. This is the cause, cooling effect will be there. Okay, cooling effect, heat release होता है, and then they become temperature and heat, two things. So, as I said, you know about this, like, energy cannot be created nor be destroyed, it only changes from one form to another form. Okay. So, in the heat budget part we will study. Let us do one thing. I request you all now, your basic reference is your NCERT class 11th, Fundamentals of Physical Geography. Fundamentals of Physical Geography. Class 11, Fundamentals of Physical Geography. Okay. Do study these chapters on earth, composition of the earth, atmosphere, all these things are given. और कहीं से नहीं, उससे पढ़िए पहले. First is your NCERT book. You see, you will get a lot of things. By the way, because of this, what happened here, due to this particular nature, as I said about fundamental physical geography here, this particular property, that is like Earth atmosphere, is being heated up by terrestrial radiation. यही तो मेजर कॉज है कि आप while you are going up, density of air is less. So what is happening? Because density of air is less, heat exchange rate is less, I told you. Another things I told you that with increasing height, the impact of what is there? The impact of long wave terrestrial radiation will be less. Cooling space between molecules is very low. Yes, you are right. Spacing is less, but first they moved, first because of they move upward. As such, gravitational attraction कहाँ ज़्यादा है बताओ? Lower atmosphere होगा. Just look at your fundamental things like please. Because of more gravity, gravitational attraction, it will goes down. Sinking of air will be there. If there is a heavier one, definitely sinking of air, if it is there. But here what is happening? There is cold and dry air. It is cold and dry. Moisture नहीं होगा. जब void space में moisture होता है, यहाँ moisture नहीं होते हैं, मगर dry होते हैं. Cold and dry air होगा. So this air, like in this case, that is not the only cases here. While it goes up, there is density will be less because of the gravity. Gravity is the major role here. Gravity plays the most important role. Think about this, or else we can have later on about these things in detail. Okay. Let us look at again about this terrestrial radiation. I told you in the troposphere we have the terrestrial radiation and how there is change in the temperature. I said that in this troposphere all these things will happen up to where the layer is up to tropopause. ये टेम्परेचर घटेगा यहाँ कहाँ तक? ट्रोपोपॉज में constant रहेगा almost. Whether this will be same with every year, every place or not. Let us see now. This lapse rate is same everywhere or not over our lower troposphere itself. Let us take the example of 3 places. Okay, मैं 3 place का example लेता हूँ. This is place 1, A, B and C, 3 places I will take example here. Let us say we are at 10 kilometer height. From 3 places I am saying. Let me take, this is as Kolkata. Here it is as at Indore. And this is at Jaipur, or let us talk about Jaisalmer. Jaipur, you know about it, Jaipur. Jaipur in Rajasthan, you know it. Indore in Madhya Pradesh, you know it. Let me tell you that in these 3 places, now we will take temperature of the ground and the 10 kilometer above this. Let us say at Jaipur, at Kolkata it is 30 degrees Celsius at the ground. Indore it is 35 degrees Celsius and at Jaipur it is 40 degrees Celsius. Okay. Now you tell me one thing. If I will go up at Kolkata and 10 kilometer height, if I will go and I will measure this, इन जनरल व्हाट हैपन, मैंने क्या कहा आपको 6.4 और 6.5. लेट अस टॉक अबाउट 6.5. लेट अस से. So if there is normal case, if it is there like 6.5 degrees Celsius per kilometer, it will be decreasing. Now in 10 kilometer, how much it will be? Minus 65. It will have temperature minus 65 degrees Celsius. So 65 degrees Celsius, it will be deducted here. So whatever plus is a 35 here. So anyway, 65 degrees Celsius, the rate of the whatever is the surface temperature minus x minus what is there, surface temperature is there, minus 65 will have, like it is minus 65 degrees Celsius. जो है ना rate of change है minus 65 में जाएगा. So if it is 35 here, if it is 35 here, so minus 65 is 30 डिग्री सेल्सियस, माइनस 30 डिग्री हो जाएंगे यहाँ. आई होप यू गॉट इट. पर किलोमीटर अगर 6.5 है, 10 किलोमीटर में कितना होगा? 65 डिग्री सेल्सियस रिडक्शन होगा. इज दिस विल बी सेम इन ऑल दिस केसेस? कोलकाता, इंदौर और जयपुर, क्या सब में समान होगा ये? यस, टेल मी. बताइए मुझे. माई क्वेश्चन इज सिंपल. वेदर जयपुर, इंदौर एंड कोलकाता, एवरीवेयर द रेट ऑफ चेंज इन टेम्परेचर विथ हाइट विल बी सेम और इट विल बी डिफरेंट. ओके, आई एम आस्किंग यू. नो. व्हेयर यू विल हैव मैक्सिमम, यू टेल मी. सडनली चेंज कहां होगा टेम्परेचर? कोलकाता में, जयपुर, इंदौर. इन दिस इट डिपेंड्स ऑन व्हाट? सी लेवल इज डिफरेंट, दैट्स व्हाई वी आर सेइंग. इट डिपेंड्स ऑन व्हाट, यू नो, ह्यूमिडिटी इन आवर एयर. व्हिच वन एयर मोर ह्यूमिडिटी? दिस इज हॉट एंड humid. This one will be hot and dry. This is average between these two gases. देखो, air of these three. Jaipur will be minus 25, you are saying. क्यों? If it is normal then only. No my dear, it is not like that. देखो क्या हो रहा है. This is hot and humid air. Here is hot and dry, very hot and dry air. Or hot and very dry air. Hot and very dry air. Average. Average condition here. Average of these two. Average we take it as आपकी जो हमारा जो लाप्स रेट जो लिया है ना 6.5 डिग्री, this is average. This here you have normal lapse rate. यहाँ पे normal lapse rate होगा, that is minus 6.5 डिग्री सेल्सियस पर किलोमीटर. ये लागू होगा यहाँ पे. But this is here. This will Kolkata, like the water, you know, coastal area have impact of the ocean, due to which it gradually heated up, gradually it cooled down. होता है ना. इसीलिए विंटर में यू हैव, इवन इन द विंटर इन कोलकाता टेम्परेचर गोज टू अराउंड 20 डिग्री, 18-20 डिग्री रहता है, 22 डिग्री, 25 डिग्री इवन. बट ऑन द कंट्रारी यू गो टू दिल्ली, विंटर टेम्परेचर डिप्स डाउन इवन टू 6 डिग्री, for couple of days or week, even December, January, the temperature goes to below 10 degree. So this is where the cold condition, Delhi has different one. Now if you go to Rajasthan desert region, we will find out summer season very hot. In the daytime temperature may goes up to 50-55 degree, night it goes to 10-12 degree. So range of temperature is more if you go away from the coast to the continental part. Do you know about this? इसको समझने के लिए हमें वो करना पड़ेगा. देखिए आप, how it is. To know about all these, we need to find out. देखो, let us say I am going from Kolkata to where? I am here at Kolkata. Kolkata is here. I'll go in this way. Then at Kolkata, if in the, let us say about in the winter night, if you go for, let us talk about the winter season. In winter, day and night temperature. Here you see, here day and night temperature, here day and night temperature. You will be surprised to see day temperature at Kolkata, it may go up to 35 degree, 30 degree. Night temperature will goes down to around 18, 20 degree. 20 degree. In winter, here the temperature, if you will see, here is a, not 20, 25 degree, nearly 20-25. Day and night temperature range is very less. But in the Jaisalmer area, this side, night temperature may be, up to 5 degrees Celsius. Day temperature goes up to 35 degrees Celsius. So difference here is how much? Difference is 30 degree. Here difference equal to how much at Kolkata? Here around 5 degree. Are you getting this? And at Indore, if I will see at Indore, the day temperature may go up to 20 degree. Night temperature or 20, instead of 20, that is like day temperature may go up to, here it is 27, 28 degree. Night temperature may go up to, we have like 18 degree. So we have difference will be at this is 10 degree. आप देखो जैसे हम from Kolkata, Indore to Jaisalmer if you go, day and night temperature range also gradually increasing. Day and night temperature at Kolkata is very less, range will be very less. At Indore, because of continentality, it will be more. At this side in Rajasthan, it will be again more because the air of these three regions are different. That's what I want to say. Air of your Kolkata is hot and humid, so it can trap the heat energy. As you know about latent heat, I hope you all are well aware with latent heat. Because of latent heat में क्या होता है यहाँ पे, जैसे कि स्टीम आपको फॉर एग्जाम्पल खाना बना रहे हो आप, स्टीम लग गया यहाँ हाथ में और फ्लेम लग गया, जलन किस में ज़्यादा होगा? इन विच केस वी हैव मोर प्रॉब्लम. इफ स्टीम इज मोर पावरफुल देन द फ्लेम हियर, फ्लेम में जो बर्निंग होगा उससे ज़्यादा दर्द होगा किसमें? स्टीम में. Steam has energy, as I said, it is energy inside. Latent heat is inside. There is latent heat in this. In case of steam, we have the latent heat, and this latent heat leads to all these things. So, if there is latent heat, heat release जो है ना यहाँ पे, heat जो है ना, heat release जो है जल्दी नहीं होगा. Gradually it heats up, gradually it cool down. A hot and humid area, this is a moisture is there, moist है ना, gradual heating and cooling होगा. Here it is quickly heated up and quickly cools down. जल्दी ये ठंडा भी होगा. It is average condition. Neither it will quickly, it takes some time, not too far, not. Okay. In the West Bengal there is coastal area. That's why you have like this. In Rajasthan and MP, why so different? Rajasthan MP में क्यों होता है? It is only because, as I said, you know, there is hot and dry. बोला ना यहाँ moist, humid air, ये very dry air, average air. देखो आप latent heat का बात. So ये ट्रैप करता है हीट एनर्जी को यहाँ पे, इसीलिए रेंज जल्दी गर्म नहीं होगा, जल्दी ठंडा नहीं होगा. ये जो है ना जल्दी ठंडा जल्दी गर्म हो गए because it radiate the energy, the heat energy very quickly. It heated up very quickly as well cools down very quickly. जल्दी होगा. जैसे कॉन्टिनेंट और ओशियन में आपको देखो जो किनारे में है, ड्यूरिंग द डे टाइम हैव यू सीन दिस थिंग्स लाइक यू नो द एयर फ्रॉम द ओशियन इट कम्स टू द कॉन्टिनेंटल पार्ट. ये तो पता है, यस और नो? यू नो अबाउट दिस लैंड ब्रिज व्हिच यू कॉल्ड. देखिए आप ड्यूरिंग द डे टाइम, if this is the ocean here, it is the ocean. Another example I am giving, okay, and this here is the continent. Day time क्या होता है यहाँ पे? During day time it is very hot, but here it is cool. So cool है इसलिए ठंडा है तो high pressure होता है, and here hot है so low pressure होता है, due to which wind blows from the ocean to the continent. Daytime. This is called as what? This is called as, popularly called as, this is called as sea breeze. Sea breeze कहते हैं. But on the contrary, in the night time what happened? Let us see. In the night क्या होता है? This became cool. Night में cool हो जाएगा और ये हो जाता है वार्म. सो बिकॉज ऑफ दिस व्हाट हैपन हियर, बिकॉज इन द नाइट इट बिकम कूल. कूल होगा तो ये क्या होता है? हाई प्रेशर हो जाता है. वार्म होगा तो यहाँ पे लो प्रेशर. सो विंड विल स्टार्ट ब्लोइंग फ्रॉम द हाई टू लो प्रेशर. हाई टू लो प्रेशर. ओके, सो इसको क्या बोलते हैं? ये वी कॉल इट एज लैंड ब्रिज. क्या बोलते हैं उसको? लैंड ब्रिज. आप देखिए हियर यू सी इट कूल्स डाउन इन द नाइट क्विकली बट इट टेक्स टाइम. देखो ये आपको ग्रेजुअली कूलिंग होगा, ग्रेजुअली डिफरेंशियल हीटिंग एंड कूलिंग ऑफ द ओशन एंड कॉन्टिनेंट. Same way you have in this case, you have more moisture. Here you have moderate moisture, you have no moisture, dry air. MP and Rajasthan is no so different in moisture. Yes, they are different in moisture quality. That's why it happened. यानी कि ग्रेजुअल हीटिंग एंड कूलिंग होगा. आपको बता दूं, पर किलोमीटर सेम 1 किलोमीटर हाइट इफ विल गो, here you will have 4.5 degrees Celsius temperature. It is the known as the moist adiabatic lapse rate. moist adiabatic lapse rate क्या होता है? बिकॉज देयर इज मॉइस्ट एयर, क्योंकि यहाँ पे मॉइस्ट एयर है, मॉइस्चर है एयर में, इमीडिएटली वो कूल डाउन नहीं होगा जिस रेट में ये हो रहे हैं. एंड ड्यू टू विच क्या होगा? ग्रेजुअली हीटिंग, ग्रेजुअली कूलिंग होता है. मॉइस्ट एडियाबेटिक लैप्स रेट इज लेस देन नॉर्मल लैप्स रेट. 1 किलोमीटर जाओगे 4.5 डिग्री सेल्सियस टेम्परेचर विल डिक्रीज. एडियाबेटिक क्यों है? बिकॉज ऑफ चेंज इन द पोजिशन ऑफ द एयर मास. एयर का पोजिशन चेंज होते ही टेम्परेचर चेंज होता है. मॉइस्ट, ये मॉइस्ट एयर है ना, ह्यूमिड है, मॉइस्ट एडियाबेटिक लैप्स रेट. यहां पे क्या होगा? ड्राई एडियाबेटिक, ड्राई एडियाबेटिक लैप्स रेट कहते हैं इसको. दिस इज हियर इज कॉल्ड एज द ड्राई एडियाबेटिक लैप्स रेट. ड्राई एडियाबेटिक लैप्स रेट. ड्राई एडियाबेटिक DALR कहते हैं. ड्राई एडियाबेटिक लैप्स रेट इज अराउंड 9.0 minus 9.0 डिग्री सेल्सियस पर किलोमीटर. 9.0 डिग्री सेल्सियस पर किलोमीटर. ड्राई एडियाबेटिक लैप्स रेट. So we have -9, -4.5. इसका आधा है, ड्राई का डबल है मॉइस्ट में. आई मीन मॉइस्ट वी हैव हाफ ऑफ द ड्राई. ये जल्दी कूल होगा, जल्दी ठंडा होगा. सो आप मुझे अब बताओ, अभी देखो आप, दिस विल बी हियर -90 एंड +40 इक्वल टू -50 डिग्री सेल्सियस. यहाँ होगा, यहाँ पे होगा -50 डिग्री सेल्सियस. हियर हाउ मच इट विल बी? हियर इट इज -45 +30, आई मीन -15 डिग्री सेल्सियस. हियर इट इज -15 डिग्री सेल्सियस, -15 डिग्री. बट हियर व्हाट विल बी? -65 प्लस इज 35 है ना, तो -30 डिग्री सेल्सियस. -30 डिग्री सेल्सियस, -30 डिग्री सेल्सियस. आप देखा ना हाउ इट हैज चेंज्ड. मॉइस्ट एयर, ड्राई एयर एंड एवरेज एयर, तीनों केस. इज इट क्लियर टू ऑल ऑफ यू? मुझे बताओ प्लीज क्लियरली. ये कंसेप्चुअल पार्ट है. बिलीव मी, वंस यू गॉट ऑल दिस थिंग्स, ग्रेजुअली यू विल गेट टू नो मेनी थिंग्स. बहुत कुछ पता चलेगा. इज इट क्लियर टू यू? नहीं तो रिपीट करूंगा वो फिर और अलग तरीके से बताएंगे. बट आई जस्ट वांट ऑल ऑफ यू मस्ट नो दिस. द ट्रोपोस्फियर इज द जोन ऑफ मिक्सिंग ऑफ ऑल गैसेस. ट्रोपोस्फियर इज द जोन वेयर ऑल द एटमॉस्फेरिक फेनोमेना टेक्स प्लेस. Why there is a increase of temperature? रुक जाओ. We have how and why there is change in temperature in the troposphere, ionosphere हम देखेंगे आगे. पहले इसको तो देख लो. First you see this. I hope you got it. I said there is, there is a difference here. Here it is height is 50, here it height is 10 kilometer, everywhere 10 kilometer height. All these cases you have 10 kilometer height. No doubt you have in all these cases you have 10 kilometer height. Still, temperature is varying. Varying temperature. Yeah, I'll explain it. See, I am not going to any technicalities. I am just saying from the very layman sense. मैं आपको बहुत ही easy way में बता रहा हूँ. You just try to think about this. If you have, you can see here. मैं एग्जाम्पल लिया क्या, ये कोलकाता है. In West Bengal, we have coastal area. We have near the coast, not far away from the coast here. Indore in Madhya Pradesh at the central part. Jaipur at the western part of India completely. So Rajasthan में ये पूरे dry air, hot and dry air at Jaipur generally, hot and dry air. Hot and moist air you will get it at our Kolkata, and intermediate between this is also hot and average condition of the air you have here. Increasing aridity if you go from Kolkata to Jaipur. So क्या होता है, if there is presence of moisture in the air, they trap the heat energy, gradually it cool down, gradually it heated up. Heating जो होता है ना, धीरे धीरे होता है, और कूलिंग भी धीरे धीरे होता है. Okay, it is very gradual. But in case of dry air, heating is very quick as well as cooling part is very quick. Quickly it happens. Both heating and cooling both takes very quickly. Right? Both takes very quickly. Both heating and cooling will be very quick in that case. यहाँ पे. So during the night, यहाँ पे क्या होगा जयपुर में देखो, during the night because of terrestrial radiation हो जाता है, heat radiate कर जाते हैं. In the night the temperature dips down to single digit. ये बहुत ही कम हो जाएगा. During the daytime it goes very high up to 45 degree. 40-45 degree Celsius temperature. Very night temperature बढ़ जाएगा. Okay? Here night temperature may increase in this case. मैंने एक जगह पे ये दिया था ना, देखो यहाँ पर नाइट टेम्परेचर देखिए, डे टेम्परेचर and night temperature differences is more here. Day and night temperature will be very high. आप D मतलब यहाँ पे डिफरेंस लिखा है, ये डिफरेंस है, ये डिफरेंस है, रेंज और डिफरेंस है ये. दिस इज रेंज और डिफरेंस. आपका यहाँ पे जैसे मैंने कहा, these three places here temperature in this case in the desert area gradually cool down, gradually heated, suddenly cool down and suddenly heated up. दिन में टेम्परेचर यहाँ पे डे टाइम टेम्परेचर एंड नाइट टाइम टेम्परेचर अगर हम यहाँ देखेंगे और यहाँ देखेंगे, डे टेम्परेचर में गो अप टू 45 डिग्री, नाइट टेम्परेचर में गो अप टू 10 डिग्री. तो टोटल जो है ना -35 डिग्री की टोटल जो डिफरेंस है 35 डिग्री डिफरेंस. डी इक्वल टू डिफरेंस कितना हो रहा है, डिफरेंस इक्वल टू 35 डिग्री है. 35 डिग्री डिफरेंस है कि नहीं. यहाँ पे मगर हम अगर देखेंगे इन कोलकाता डे टाइम टेम्परेचर एंड नाइट टाइम टेम्परेचर, इफ यू सी डे टाइम टेम्परेचर अराउंड 25 डिग्री सेल्सियस, नाइट टाइम टेम्परेचर समवेयर अराउंड 15 डिग्री या 20 डिग्री सेल्सियस, 20 डिग्री सेल्सियस, 20 डिग्री. यहाँ पे डिफरेंस कितना आएगा, डिफरेंस इज 5 डिग्री सेल्सियस. देखो कोलकाता में कितना कम डिफरेंस है. डिफरेंस क्यों होते हैं, बिकॉज इट रिटेन द टेम्परेचर फॉर लॉन्ग टाइम एंड ग्रेजुअल, दैट्स व्हाई इट कूल डाउन. ये जो केस है, दिस टाइप ऑफ केसेस लीड्स टू चेंज इन द बिहेवियर ऑफ द चेंज इन टेम्परेचर. मैं कहा इसको क्या है, इन द कोलकाता एयर विच इज देयर इज नोन एज मॉइस्ट एयर, So we said this as moist adiabatic lapse rate. There is change in the temperature with increasing height, but this will be in a gradual phase. In case of this site you have, in case of your Rajasthan, क्विक चेंज हो रहा है -9 डिग्री सेल्सियस पर किलोमीटर हाइट। 1 किलोमीटर ऊपर जाएंगे 9 डिग्री घटेगा। यहाँ पे जो है 1 किलोमीटर ऊपर जाएंगे तो कोलकाता में 4.5 डिग्री घटेगा, उसका आधा ऑलमोस्ट। सो दिस इज द कॉज एज डिफरेंट टाइप ऑफ lapse rate. So lapse rate here is, in case of moist air, lapse rate is -4.5 degree Celsius. In case of dry air, it is 9 degree Celsius, but average is 6.4 to 6.5 degree Celsius. You must remember this. This is very, very important. You must remember this, and please, based on this, you have to discuss lot of things related with the atmosphere. इसी के बेसिस पे हम एटमॉस्फेयर की बहुत सारी चीज़ें डिस्कस करेंगे, इसीलिए हमें इम्पॉर्टेंट है ये जानना. वी नीड टू नो. सो lapse rate is not everywhere equal. The lapse rate in the troposphere varies with respect to place. So at the coastal area, lapse rate will be gradual. At the continental part, lapse rate will be very quick. Continent का एरिया में lapse rate बहुत जल्दी होगा. यहाँ पे टेम्परेचर बढ़ना और घटना बहुत जल्दी होगा एज कंपेयर टू दिस रीजन्स. इज इट क्लियर नाउ? इज इट क्लियर नाउ? अभी ये क्लियर हुआ क्या? सो आई विल मूव ऑन नाउ टू द एप्लीकेशन पार्ट. दैट दिस इज ड्राई एडियाबेटिक लैप्स रेट, मॉइस्ट एडियाबेटिक लैप्स DALR 9 डिग्री सेल्सियस, मॉइस्ट एडियाबेटिक WLR भी बोलते हैं, वेट मॉइस्ट और वेट एडियाबेटिक लैप्स रेट. ओके, इट इज हाउ मच? -4.5 डिग्री, एंड इन बिटवीन दिस एवरेज इज 6.5, normal lapse rate. 3 types of lapse rate you have: wet, dry and the normal lapse rate. Wet, dry and the normal lapse rate. Okay, clear? Is it clear now? Okay, thank you. So it's clear now. Now I'll move on to the next point. Here I was saying that in the troposphere it will change. On an average 6.5 degree minus 6.5 degree Celsius per kilometer. This is here is lapse rate of troposphere. But troposphere में ये change होगा up to tropopause. Beyond this it will not go for. ट्रोपोस्फीयर में यही यहाँ तक रहेंगे. ट्रोपोपॉज, पॉज मीन constant temperature you have there at the tropopause transitional zone. After crossing the tropopause, temperature increases here. क्यों increase होता है अभी देखते हैं. Some of your friend asked me here why. So troposphere के बारे में detail you got it. So please note down. Troposphere is the zone of life zone, है ना. So hence troposphere is the life zone of the atmosphere. Atmosphere is the life zone of the atmosphere. Troposphere is the life zone of the atmosphere. Atmosphere की life zone तो troposphere ही है. The life zone of atmosphere is troposphere. I said almost all atmospheric phenomena develops here. I told that almost all atmospheric phenomena, यहीं पे ही सभी atmospheric phenomena होते हैं. This is the zone where almost all, as I said, related disturbances, atmospheric disturbances and all other things happen in these regions only. यहीं पे ही होगा और कहीं पे नहीं. Troposphere is the life zone of the atmosphere. That's how I said. I hope you got it now. Let me again go on to other things. अभी और एक चीज देखते हैं हम यहाँ पे, if it is there. Troposphere, if it is clear, I'll go for now stratosphere. In the stratosphere, what happened? लिखो, stratosphere, which extends from the tropopause to stratopause. That is, tropopause to nearly 50-60 kilometer. Nearly 60 kilometer. In some book it is given 60 kilometer है, 60 किलोमीटर रहेगा. 60, 50 to 60 नहीं करके आप 60 कर दो इसको. Most of the authors are about 60 kilometer. Nearly 60 kilometer from here. Stratopause. Troposphere, density of air changes because of weight. See that density depends on so many things. Density depends on again temperature. Another point is moisture content. Another point is pressure condition. PV equal to nRT, you know it. Pressure, volume and temperature की relationship. It is in a closed system. Our atmosphere में यहाँ पे देखेंगे तो open system है. So does the tropopause maintain a constant temperature? If so, what is the reason behind it? Constant temperature mean देखो ये zone of mixing है. यहाँ पे ये nearly 2 to 7 किलोमीटर thickness की एक zone है. Zone of transition where there is no sudden change. Rather there is like that's why no sudden change. So इसको क्या कहते हैं? Because of its homogeneity, in fact, consistency रहता है temperature. It is a thin layer, बहुत thin layer होता है ये tropopause. So beyond the tropopause in the stratosphere, why temperature increases? In this zone, you know what happened? There is an increase in temperature because of O3, ozone. Ozone will be there up to this layer. Ozone जो है ना, ozone layer, ozone is O3, no, ozone, isotope of oxygen की है ना ये. So this is here is O3 bonding takes place, and in the upper stratosphere a concentration of ozone is more. So let us note down this point. Stratosphere is a thin zone where there is an increase in temperature with increase in height. Called as temperature inversion, called as inversion of temperature. Called as inversion of temperature. Okay, temperature inversion कहते हैं. ये completely लाप्स रेट के ऑपोजिट है. ये कंसेप्ट जो है ना completely opposite to the lapse rate. Stratosphere is a thin zone where there is an increase in temperature with increase in height, called as the inversion of temperature. Okay, this phenomena is primarily due to this phenomena is primarily due to what? This phenomena is primarily due to increasing concentration of ozone with the increasing this phenomena is primarily due to the increasing concentration of ozone with increasing height. And as you know, with increasing height there is increase in, मैंने कहा कि ओजोन concentration, ozone layer traps UV rays, filter and traps heat energy. Ozone layer filters the harmful ultraviolet UV rays. Ozone layer filters the harmful ultraviolet rays or UV rays and traps the heat energy. तो एटमॉस्फेयर हीट एनर्जी जो है ना उसको ट्रैप करके रखता है. दिस इज द कॉज इनफैक्ट हेयर, ट्रैप्स द हीट एनर्जी ऑल्सो हेयर. सो टेम्परेचर तो वहाँ का बढ़ेगा इसीलिए टेम्परेचर बढ़ता है. विद इंक्रीजिंग हाइट देयर इज इंक्रीज इन द टेम्परेचर ऑल्सो हेयर. ओके, देयर इज एन इंक्रीज इन टेम्परेचर विथ इंक्रीजिंग हाइट. देयर इज एन इंक्रीज इन टेम्परेचर विथ increasing height. Okay, this phenomena is primarily due to the increasing concentration of ozone with increasing height. I said ozone layers filters the harmful UV rays and traps the heat energy. You must remember this, it traps the heat energy. Okay, this is here is very important, right? Is it clear? Okay. Now आपका जो क्वेश्चन था क्यों ये बढ़ता है, इस पे अगर O3 ओजन कंसंट्रेशन बढ़ता जाएगा, टेम्परेचर यहाँ पे बढ़ता जाएगा, बिकॉज ट्रैपिंग ऑफ हीट विल बी मोर. Density of this one increases up to here. Ozone layer after certain point also it decreases. ऊपर जाएगा तो, because there is thinning up of the ozone layer in mesosphere, धीरे धीरे घटता जाएगा. So टेम्परेचर वहाँ पे धीरे धीरे क्या होगा, घटता जाएगा, because there is a gradual decrease here. Gradual decrease in temperature with increasing height. यहाँ पे concentration of ozone layer is more in the mesosphere lower part. जैसे ऊपर जाएंगे ना ओजोन घटता जाएगा, so temperature will decrease. I hope you got it now. Stratosphere में बढ़ने का मेजर कॉज है increasing ozone concentration. Now note down something about stratosphere again. Stratosphere stratosphere, you remember one thing, there are high cloud even sometimes, mother of pearl cloud or stratus cloud बोलते हैं. There are sometime clouds also you will get in these regions. So एक डिवाइड ऑफ क्लाउड ऑफकोर्स ट्रोपोस्फियर तक क्लाउड होते हैं, इथे मदर ऑफ पर्ल क्लाउड एक बोलते हैं, एक दैट इज दे डोंट गिव रेनफॉल इवन ट्रोपोस्फियर में. आई होप यू हैव सीन दिस दैट डायग्राम हियर वी हैव लाइक ट्रोपोस्फियर इज गुड फॉर व्हाट, एयरप्लेन के लिए क्या अच्छा है, ये रीजन से अपर ट्रोपोस्फियर एंड लोअर स्ट्राटोस्फियर इज गुड फॉर द लॉन्ग डिस्टेंस एयर ट्रैवल, ये अच्छा रहेगा. इन केस ऑफ मेजोस्फीयर ऑन द कंट्रारी इट इज डिफरेंट. मेजोस्फीयर में मैंने अभी जैसे कहा था कि मेजोस्फीयर विल बी डिफरेंट इन टर्म्स ऑफ टेम्परेचर ग्रेजुअली डिक्रीजेस हियर, बट स्ट्राटोस्फीयर में टेम्परेचर धीरे धीरे इंक्रीज कर रहा है बिकॉज ऑफ हियर O3 ओजोन विल बी मोर, here it will be less, here will be हो गई नहीं, so with increasing height there is decrease in temperature here in mesosphere, but with increasing height increase in temperature at stratosphere. Okay, let us now, there is nothing much about this in fact, ज़्यादा कुछ नहीं है इसके बारे में, so I'm not giving you much on this, but yes there are few things which you need to look at and you have to find out in the prelim. Especially for the preliminary exam they are giving question on characteristics of each layer sometimes. Okay, so we need to see that. Let us see. Troposphere you got it, mesosphere you got it. Troposphere, stratosphere. Mesosphere पे चलते हैं. Mesosphere. What are this mesosphere? It extends between the stratosphere and stratosphere and where? Ionosphere. Stratosphere and ionosphere. Between the stratosphere and the ionosphere you have this. Between the stratosphere and ionosphere 60 to 100 kilometer. So in this case we have what is there in the mesosphere, it extends from, I have written here, it extends from or extend between the stratosphere and ionosphere or stratosphere. Stratopause it will be, okay, and mesopause, that is between the stratopause and the mesopause. So in this zone, what happen here? Temperature will gradually decreases here. Temperature decreases with increasing height. Temperature decreases with increasing height here. Temperature. My friends, here is a question on temperature inversion in hilly area. A radiational inversion है और air mass inversion, sinking of the air. We will have a separate discussion about temperature inversion later on. पहले लेयर को देख लो आप क्या क्या है. Stratosphere and the ionosphere. Stratified regions. लिखो one thing. This is the mesosphere is known for what? Mesosphere is the central zone, है ना? Mesosphere is the middle zone of the atmosphere. Middle zone of the atmosphere. Middle zone of the atmosphere is the mesosphere. You remember this? Mesosphere. There is no other things about this. Again you ask me, so you ask this, what is the reason for inversion in temperature in hilly area in the time of winter? Winter में inversion होने का major cause क्या है? Winter में dry रहता है comparatively आपका air, और winter में radiation जो है ना, जो हो गया जल्दी radiate कर जाएंगे. This particular from terrestrial radiation will be quick. So what happen? Because आपके यहाँ पे ड्राई एयर है तो रेडिएशन विल बी क्विक. रेडिएशनल इन्वर्जन होता है नीचे जो है ना लोअर एटमोस्फियर, बिकॉज इट कूल डाउन वेरी क्विकली, इट इज कूल एज कंपेयर टू द अपर पार्ट. सो अपर पार्ट वी हैव टेम्परेचर विल बी देयर. नाउ रेडिएशन जब होता है वहाँ पे अनदर थिंग्स इज देयर इन द दिस रीजन्स, माउंटेनियस रीजन, हिली एरिया. क्या होता है? फ्रॉम द अपर रीचेस कोल्ड एयर दे रश डाउनवर्ड, व्हाइल द एयर कोल्ड एयर दे रश डाउनवर्ड. They lifted up the warmer air from valley regions also. This also caused this. Okay, we will have a discussion later on this in detail. हम डिस्कस करेंगे आगे. ये अभी देखिए जोन्स ऑफ दिस ट्रोपोस्फियर एंड स्ट्रेटोस्फियर. ट्रोपोस्फियर, स्ट्रेटोस्फियर, मेसोस्फियर हो गया. Then I'll go to the ionosphere. Beyond this you have the ionosphere. Ionosphere is important for us for your exam. Ionosphere क्या है? यहाँ पे ionosphere as it is saying, it is the zone of different ions. There are different ions in this zone. There are zones of different ions in this zone. There are different ionic zones here you have. So ionosphere में क्या होता है? In the ionosphere, troposphere, stratosphere, mesosphere, then ionosphere. There are ions and free radicals here in this entire zone in the ionosphere. Okay, please note down here. In this zone, ionization takes place, a process by which atoms are changed into ions. In this particular stage, atoms are changes to ions. What? Through removal of or addition of through change in the number of electron through removal or addition of electron. Okay, through removal और कर दो और addition of electron. Atoms are changed into atoms changes into कर दो atoms changes into in some time atoms are changed into ions through removal or addition of electrons. ये होगा ionosphere में generally it happens, naturally it happens. Okay, which leads to generation of what? Which leads to giving rise to which leads to or which develops electrical charge also. चार्ज होता है आयनोस्फीयर में. Here is a good question somebody has asked. Why the tropopause is different at pole and at the equator? अरे मैं तो बोल चुका हूँ भाई ये इतने बार. Okay, at the end I'll take all these questions. Fine, I'll explain it to you. Look at here. Atoms are changed into ions. So addition electrical. So electrons addition or you can say the removal of electron which develop electric charges. So इस पे क्या होता है in that regions what happen here? So heat energy also because of ionic exchange there is development of heat energy also. We have ionic exchange leads to heat energy also. Okay, ionic exchange leads to ionic exchange also releases heat energy. Ionic also releases heat energy, also produces heat energy. So a very important thing heat energy you are getting here. So there is an increase in temperature with increasing height. Ionic exchange also produces heat energy and so there is an increase in temperature with increasing height in this zone. जितना आप ऊपर जाएंगे ना ये टेम्परेचर बढ़ता जाता है. Ionic exchange is there. There are different zones of this ionosphere. Ionosphere has different zones also. On it you have different zones also. The ionosphere also have the D layer, the E layer, D layer, E layer, sporadic E layer, sporadic E layer, sporadic E. Okay. E2, F1, F2 layer, E2 layer, F1 layer, like this you have E layer, D layer, Okay, this type of zones you have with different characteristics. ये ionosphere further subdivided है इसे. You got it? What I am saying? We have different fragmentation of those. We have also G layer like this. All this takes place. D layer जो कहा मैं ये 60 to 99 किलोमीटर D लेयर जो होता है अप टू 110 किलोमीटर तक होगा. वन 130 किलोमीटर 9 into 130 E layer is around 130 किलोमीटर 110 होगा ये नियरली 110 110 to 130 gradually. No need of memorizing everything, no doubt, but there is a change here. Sporadic E2 is nearly आपकी ये हो जाता है करीब 150 किलोमीटर. Sporadic layer A is somewhere this is 30 transitional zone between these two. Yeah, at the transition between these two you will get F1 F2 layer and the G layer. F1 F2 है 150 to 380 हो जाता है. F1 F2 up to 380 किलोमीटर. Beyond this, as I said about the G layer is around 400 kilometer or above. 400 kilometer or above. You have 400 kilometer or above. So this type of development you are having. ऊपर जितना जाएंगे temperature changes होता रहेगा इससे. As I said about the D layer, they generally E layer is called as Kennelly Heaviside. E layer called as Kennelly Heaviside. You must remember this Kennelly Heaviside and Appleton layer. Though sporadic E layer is Kennelly Heaviside layer and F1 layer it is like Appleton layer. F1 is the Appleton layer. ये दोनों लेयर ठीक से याद रखिए. Appleton layer and Kennelly Heaviside layer. This is the derivation or this is the again further subdivision of the ionosphere. Ionosphere की ये है यहाँ पे. Remember one thing that some of these layers they develop during the daytime. Some of these they develop during the night time. कुछ जो लेयर है डे में होता है, कुछ जो होता है नाइट में होते हैं. Depends on the solar rays and so many things are there. E layer is 110 to 130 kilometers. Kennelly Heaviside I said, and F1 layer I said Appleton layer. Appleton. दोनों you must remember one thing. Long distance radio wave communication, for which it plays a very important role. Okay, please note down now this point. The ionosphere generally helpful for, the ionosphere is helpful for long distance radio wave communication. Long distance radio wave communication is because of this layer only. यही लेयर के वजह से ही लॉन्ग डिस्टेंस रेडियो वेव कम्युनिकेशन हो पाते हैं. हमने कहा रेडियो वेव कहीं पे भी यूज हो, रेडियो वेव का आपको ये कराया जाता है. I have no idea about how it influences or is it influencing the radar and all, but I have one thing I'll say, for radio wave communication it helps a lot. आपने देखा होगा ना, during the night time in the short wave radio channel, short wave, they are very clear, but in the daytime you will not get it, because daytime this is absorbed by some of the ionospheric layer which develop during the daytime, while they interact with the photons, the energy capsule which is coming from the sun. They interact with earth, this particular ionic zone, ionosphere, they form different type of, at that time they form in many cases different types of temporary zone, different type of temporary zone. Okay, and this also happen. Okay, this is one part you got it, I hope. Let us see now another point. अगर ये हो गया, I hope you got it. Here you need to remember Kennelly Heaviside and Appleton, दो लेयर को आप जरूर याद रखिए. D layer also affect these things. Kennelly Heaviside मीडियम एंड हाई फ्रीक्वेंसी रेडियो वेव को भी वो करता है. ओके, Kennelly Heaviside layer only in daytime, ये only during daytime. Sorry, Appleton layer only during the daytime. Appleton layer, Appleton during the daytime, disappear in the night. Appleton also and Kennelly Heaviside also, दोनों को दोनों ये डे टाइम पे डिसअपियर करते हैं, नाइट में क्लियर आते हैं. ओके, नाम याद रख लीजिए. these layers help in long distance radio wave communication. I hope it is clear to you all. So our Earth atmosphere, beyond this, it is known as the exosphere. Beyond this is called as exosphere. Beyond the ionosphere is called as the exosphere. We have no such major idea about this, but yes, whatever we know, that the ions and free radicals which is there, I said, ions and free radicals, whatever is there in this exosphere regions, very rarefied. Exosphere is outermost layer, RAREFID, rarefied atmosphere. It is a very rarefied atmosphere with free radicals, free radical and ions. with free radical and ions. Highly rarefied atmosphere with free radicals and ions. Highly rarefied atmosphere with free radical and ions. Highly rarefied atmosphere with free radical and ions. Okay, I said highly rarefied atmosphere with free radicals and ions here. फ्री रेडिकल और आयन यहाँ पे रहते हैं। रेडिकल आयन में रेरिफाइड एटमोस्फेयर में मतलब क्या है कि यहाँ पे यू विल हैव लाइक चार्ज पार्टिकल्स आर मोर इन दिस रीजन, चार्ज पार्टिकल्स, एंड दिस इज द जोन व्हाइल इट इंटरेक्ट विथ आवर अर्थ मैग्नेटिक फील्ड। देखो आप, हियर यू हैव ऑरोरा ऑस्ट्रालिस, ऑरोरा बोरियालिस, वॉट एवर इज देयर, aurora, these things you will get. Satellite and space shuttles you will have like in these regions only. Space shuttle, you have like satellites mostly in these regions. Aurora borealis, aurora australis. If you look at this, upper troposphere, lower stratosphere is good for airplane. For the airplane it is good. अपर ट्रोपोस्फियर, लोअर स्ट्रेटोस्फियर फ्लाइट के लिए अच्छा रहता है क्योंकि फ्रिक्शन कम रहता है, विंड की फ्रिक्शन कम होगा, दैट इज द कॉज। एस्ट्रॉइड्स और एनीथिंग विल कम इनटू कांटेक्ट विद अर्थ एटमॉस्फेयर बिकॉज फ्रॉम द मेजोस्फियर बर्निंग स्टार्ट होता है, बिकॉज फ्रिक्शन विद द एयर स्टार्ट फ्रॉम द मेजोस्फियर। आयन के बाद ये यहाँ पे मेजोस्फियर में स्टार्ट होते हैं फ्रिक्शन, स्ट्रेटोस्फीयर में पूरी तरह से जल जाते हैं। दे स्टार्टेड फ्रॉम द मेजोस्फीयर इटसेल्फ। सी हियर, मोस्ट ऑफ द एटमॉस्फेरिक रिसर्च और द आउटर स्पेस रिसर्च फ्रॉम ionosphere itself, satellite shuttles. I said about this is like aurora australis, aurora borealis, both north and south polar region, north pole and south polar region, magnetic pole is there, because of which while they interact with this magnetic pole, there is ions and all these, they got in fact they infuse with this, they form different type of I said that you will have like magnetic impulses also, a magnificent display of light you will get, bright light in the polar regions, they are called as aurora. Aurora is magnificent display of light. Aurora australis, aurora borealis. I said a display of light, magnificent display of light. Here you will get in this region, aurora कहते हैं जिसको, aurora, these are like this aurora you will find out where, in the regions wherever there is magnetic influence, impulse is more, and magnificent display of light बोला मैं, colorful lights बनते हैं ये at the polar regions of both north and south. North aurora borealis कहाँ है? Aurora borealis in the aurora borealis north pole. Aurora australis is in the south pole. Okay. Australis, aurora australis, magnificent display of light in the north pole. Borealis, magnificent display of light in the south pole because of Earth's magnetic field and the interaction with ionosphere. थर्मोस्फीयर कहते हैं ये दोनों को भी, थर्मोस्फीयर भी कहा जाता है. Ionosphere and exosphere are also called as the thermosphere. Put together these two. I hope you got some idea now about this particular zone. So there can be a question here on this in the preliminary exam, like which layer is known for what particular purpose, and I hope that you will able to do this. There also recently Troposphere, stratosphere and mesosphere are called as the homosphere. Tropostrato and meso also called as the homosphere. Okay, they are also called as the homosphere nowadays. This zone, troposphere, meso, also they are called as the, what is that zone? Homosphere. Homosphere. यहाँ से यहाँ होमोस्फीयर है. You must remember this: troposphere, stratosphere and mesosphere. Combinedly they are called as the mesosphere. Mesosphere. Okay. So because this is homosphere, mesosphere, stratosphere, troposphere. Yes, mesosphere. And above this you have heterosphere, where you have free radicals and ion मैं कहा HETERO, heterosphere. Beyond this it is the heterosphere. होमोस्फीयर एंड हेटेरोस्फीयर टू डिस्टिंक्ट जोन मैंने कहा. होमोस्फीयर ये हेट्रोजेनिटी है ना वहाँ पे, बिकॉज ऑफ द आयन्स इन फैक्ट बेस्ड ऑन डेंसिटी यू विल गेट ऑक्सीजन, हाइड्रोजन, you will get in ionic form in the upper part. They are called as this heterosphere. Hydrogen layer, oxygen layer, whatever the layers by layers you will find out in the ionic form, as I said, in the heterosphere. So anyway, homosphere and heterosphere you have two distinct zone. मैंने कहा ये modern बोलते भी हैं, but it is not needed. What is more important is this one which I have just said. What is there in which particular regions? Now there are some question I got. I'll take the questions now. First question I got about the thickness. आप देखो ये बस very easy thing this is. Let me draw that diagram which I have used. That I'll use that earlier diagram which I have drawn. Here we say आपका क्वेश्चन है कि क्यों इक्वेटर में ज़्यादा है. देखो कन्वेक्शन इंस्टेबिलिटी बोला मैं. नाउ यू थिंक फ्रॉम द सेंटर ऑफ द अर्थ, इसका जो है ना बियॉन्ड दिस द लेवल में व्हाइट में करता हूँ, ये पूरी तरह से समान है. नाउ व्हाट विल हैपन, यू टेल मी. इफ आई विल से दिस एयर ओके. नाउ इफ इट इज देयर, ये है आपकी दिस वन आई सेड अबाउट द ट्रोपोस्फियर. देखो यहाँ पे प्लीज, दिस इज द ट्रोपोस्फियर. फ्रॉम द सेंटर ऑफ द अर्थ इसका जो है ना पूरे सर्कुलर है. ये है स्ट्राटोस्फियर. इफ इट इज ए परफेक्ट सर्किल, नाउ यू टेल मी वन थिंग, डोंट यू थिंक थिकनेस विल बी मोर एट द पोल्स एंड लेस एट द इक्वेटर, होगा कि नहीं? क्योंकि ये ऐसा होगा, देखो यहाँ इट विल बी लाइक दिस टाइप ओनली. लुक एट हियर. So thickness at the pole and the equator, if you will see, here it is thin at the equator, thick at the pole. कौन सा जोन है ये? This is what is stratosphere. Stratosphere is here. Region located in the same latitude has different temperature due to their location close to the coastal region and their moisture carrying capacity. Yes, you are correct here. How short wave convert to long wave? My friend, एनर्जी जब जाता है ये एब्जॉर्ब करेगा, रिफ्लेक्ट बैक होएगा, इट डिपेंड्स ऑन द सरफेस यू नीड टू सी. ओके, एनर्जी यू चेक इट आउट, हाउ द वेव चेंजेस और एनर्जी चेंजेस इट्स फॉर्म. नाउ लॉन्ग एंड इनकमिंग रेडिएशन आफ्टर फॉलिंग ओवर द सरफेस रिफ्लेक्टेड बैक, रिफ्लेक्शन होगा ये. इसीलिए यू नो अबाउट एल्बेडो इफेक्ट. Have you ever given any thought that while you will take photographs, some people, even if their appearance is not that good, but they look very handsome, beautiful, है ना? होता है कि नहीं? Why it is? This is because of the surface on which it is reflected back. वो सरफेस का स्मूथनेस के ऊपर डिपेंड करता है, एब्जॉर्प्शन के ऊपर डिपेंड करता है, एंड बेस्ड ऑन दिस इंटेंसिटी हाउ मच इट इज देयर इट विल रिफ्लेक्टेड बैक. यूवी रेज आर एब्जॉर्ब बाय द ओजन. आपको पता है, आपको आगे ओजन डिप्लेशन में कुछ और बताएंगे कि हाउ इट इज देयर. इट इज लाइक इन एब्जॉर्ब, फिल्टर जैसा काम करता है. हार्मफुल जो भी है they usually they filter out this, filter like layer. How it is again? Ozone layer, will see ozone depletion. You said you asked about the 6 to 18 kilometer. I hope you got it. Now why the upper part there is no such any variation? इसके ऊपर क्या होगा बताओ. Now beyond this, if it is this much, beyond this what will be? अगर हम इसको यहाँ लेके आएंगे, देखो आप, देखो पूरा समान है. थिकनेस इज एवरीवेयर सेम थिकनेस हो जाएंगे. सो इट इज स्ट्राटोस्फीयर, देन दिस वन विल बी मेसोस्फीयर. दिस इज हियर इज मेसोस्फीयर. Mesosphere is here. This will be mesosphere here. Troposphere, stratosphere, mesosphere. Troposphere, stratosphere, mesosphere. Three types. Sir, you told us to remind us about geological time. My friends, will do one thing. Geological time scale के जो है ना, इसको समझना है अच्छी तरह से. To know these things, we need some practical thing. Like you know, we need the India physical part. India physical में physiographic regions of India. So I'll tell you at that time that how what type of rock was formed. वो better रहेगा सबसे, इसीलिए छोड़े हैं इसको अभी. Just for that reason only. So, another very good question here that you have given, like why lowest temperature somewhere, there is a question. I hope you got it. Why the height of troposphere is different at different pole and the equator? Troposphere क्यों है? I hope you got it. Because at the equator there is convectional instability, so air rises upward. Air rises upward. Here to move upward. On the contrary, at the cold condition, the pole is sinking down. So, here there is no convectional instability at the poles. That is the cause there is sinking of the air. Here it will go up. That's why dome shape. Like what is the tropopause? Tropopause is the zone of mixing of all gases. So, it will be better for us. Mixing of all gases होते हैं ये. Hope you got it. Now, another things. Why there is change in density of air? Change in the density of air with respect to its moisture capability, temperature, spacing between the particles, nothing else. Mesopause is the coldest zone. Why? देखिए, it is the mesosphere here. If you go up beyond this, troposphere में क्या हो रहा है? The troposphere you see, the temperature is, in case of troposphere if you see, temperature increases or decreases? Troposphere, in case of a troposphere, the temperature here in this case decreases. Stratosphere, the temperature generally देखो increases, फिर decrease कर रहा है. Mesosphere में because you see that there is no effect of moisture or anything, तो यहाँ पे temperature बहुत ही कम हो जाता है. Cool down to its highest point. That is the cause. Okay, so it will have like completely dry air. In this case, you have dry air, and with respect to height, there is a decrease in temperature, as you know. Concentration of the ozone also decreases with height there. That is the major cause. So we can say one thing here, that there is a great change in the temperature. With respect to height, there is a change in the temperature and there is change in the composition. ये एक prelim point of view, but in the mains also we got this question this time. देखो आप, troposphere is a very significant. This year this question is there. Look at here. Troposphere is the great. Here you see. Troposphere is a very significant atmospheric layer that determines weather processes. How? I haven't discussed about weather process. So we'll get to know about this. This question we got this year itself. Troposphere is a very significant atmospheric layer that determines weather process. 250 words in which you have to give the answer. Now see, in this case what happened here. इसके ऊपर one thing I would like to say, troposphere is a significant atmospheric layer that determines the weather process. How? We need to look at almost all atmospheric phenomena is related with the troposphere, I told you, with the troposphere itself. Troposphere is a zone of mixing of all gases, I said. Troposphere is the zone where you have moisture, where you have dust particles, where there is a decrease in temperature with increasing height. Moisture and dust particle, they play a significant role on cloud formation. Cloud formation and you have precipitation. You see, all this environmental condition, all this condition is here confined to only troposphere. So, troposphere in fact is the life layer, as I said earlier. Okay. This region is known for, this tropospheric region is known for what? Three things you can say. It is known for cloud formation, atmospheric stability and instability, precipitation. तीन चीज है. So that's why I hope you will able to explain this. But weather conditions हम आगे फिर again करेंगे. Cloud कैसे बनते हैं, precipitation कैसे होता है, how the cloud formation takes place. Okay, how the precipitation is there, why they are so important. Right. We have a question here. Is detail of heterosphere and homosphere needed? Not needed. Why this temperature changes in different zone? Temperature changes in different zone because of quality of the air due to change in the density of air. मैंने कहा आपको three things. Quality of air means somewhere ozone concentration is more in one layer, so you have a trapping of the heat. Lower part you have more radiation, more mixing of the gases, convectional instability is there, so they are different. I have already explained to you, just check out it is. Do I need to explain why this temperature changes in different zone? मैं आपको अभी बताया था temperature zone, temperature क्यों होगा changes. I told you this here changes is due to three causes. Lapse rate है troposphere में. Lapse rate का जो factor है वही होगा. First one, lapse rate में क्या था पहला point? With increasing height, decreasing temperature because of density of air decreases. Second is incoming solar radiation, insolation in short wave and terrestrial radiation long wave में जाएगा, तभी जाए गर्म होता है. बोला था ना, density of air is less, so heat exchange rate is less towards up if will go. Here it is more because of the more concentration of ozone. Ozone concentration gradually decreases, so it is decreasing. Here it is constant at the transition zone. Again increases because of the rarefied atmosphere, ionic exchange, etc. I told you. Right. Done it. Completed. This is temperature changes in different zone. Yes, you got it. Why ozone layer deposition found at poles? Good question it is. Ozone is found at the poles because of two causes. एक हम आगे बात करेंगे. That is about the polar regions. Wind they go out. Polar vortex and concentration of the in the troposphere में क्या है? Concentration of this sinking of the air. So you have sinking. During this it drag the ozone from nearby region. I will explain it to you with the jet stream part and polar vortex. Okay, आगे आएगा. Can you please repeat the role of dust particles in alteration of temperature? Yes, dust particle they cool down very quickly as compared to the moisture nearby. Because they cool down very quickly, while there is some moisture nearby, it cool down, it become frozen. Condensed हो क्या होगा? आसपास जो nearby regions, whatever moisture is there, it attract because of cohesive force they got attracted nearby moisture and it forms a heavy one, and the raindrop formation takes place on this. So in this way the cool down, so it will have like latent heat whatever is there in that particular, it get released also. So again it take more and more moisture. आगे rainfall development of raindrops में बताएंगे, cloud formation में बताएंगे. These are very important. First you remember dust particle plays an important role because it cools down quickly, heats up quickly. प्लीज गिव ए नोट्स ऑन डिफरेंट फैक्ट्स और इवेंट्स हैपन इन डिफरेंट लेयर. ठीक है, थैंक यू. लेट अस डू इट नाउ. नोट डाउन व्हाट इज देयर इन ट्रोपोस्फियर, स्ट्रेटोस्फियर में जब देखते हैं अभी. नोट डाउन हियर इन द लोअर ट्रोपोस्फियर, in the lower troposphere, देखो आप what is happening here. In the lower troposphere, friction takes place, more friction because of the, what is that, topographical variation. Because of relief variation, friction will be more. Friction will be more with what? Lower troposphere में क्या होगा बताइए? Friction will be more. Yes or no? So friction is more, so velocity of the air is less here. ठीक है यहाँ पे. So this lower part, lower atmosphere, lower troposphere, friction will be more, and this is like because of frictional drag, wind velocity is less. But in the upper troposphere, velocity of wind is more. Velocity of the wind more. So upper troposphere is known for jet stream and all, very high velocity wind system. Okay, लिख लिया. Upper troposphere very high velocity wind system. Next point लिखो. Upper troposphere and lower stratosphere is good for what? Airplane. Good for air navigation because it has less frictional drag. Less frictional drag. Frictional drag will be less because of that. Okay. Now coming to this part here, stratosphere. In the stratosphere, I told you we have like friction will be less and all, that's why we have for airplane and all. Then we go for like mesosphere. Mesosphere mein asteroids generally found in these, and the comets, shooting stars. Shooting stars mostly while they comes in contact with earth gravitational field, and when these have friction with this, friction होगा तो ये क्या होता है, it burnt out. मेजोस्फीयर में होते हैं. Now aurora australis, aurora borealis, etc., they usually found in the ionosphere and exosphere. Mostly in the iono and exosphere. They are known as combinedly iono and exosphere known as thermosphere. So this region here you have mostly aurora borealis, aurora australis. This layer is also good for satellites, but it has one thing, one problem is there, that is whenever there is sunspot cycle or any disturbances on the sun magnetic field, it has disturbances here also. Okay, ये होता है. Next question है, I hope you have written these facts now, no problem. Why Appleton layer and Kennedy Heaviside layers present on the daytime? क्या होता है डे टाइम पे सनरेज इज देयर, तो सनरेज क्या करते हैं, सनरेज इज फेजिंग क्या हो, एनर्जी कैप्सूल्स लाइक नोन एज फोटन, सोलर विंड एंड फोटन दे थ्रो, all these come in contact with the earth's magnetic field. When it comes in contact with earth's magnetic field, it got trapped here, and you have magnificent display of light known as the aurora, aurora australis, aurora borealis. Now during the daytime what happen here, this particular ये नाइट टाइम पे होते हैं, डे टाइम में क्या होगा, इन द डे टाइम generally the ions they got charged with the, I said that with these solar photons, and these ions they only form a thin layer like because of action or reaction with them in daytime only. It requires only sun rays. Sun rays नहीं होगा तो नहीं होगा. In the night they are absent, Appleton and both the layers, because they need solar photon or sun rays. Okay, another one. How does they help? They help, can leave it. They help in the, because they reflect back the radio wave. उनका लेयर जब होता है रिफ्लेक्ट करता है तो ये अच्छा रहता है. कुछ लेयर होता है एब्जॉर्ब कर लेते हैं, एब्जॉर्ब करेगा तो सुनाई नहीं देगा, बिकॉज दे रिफ्लेक्ट बैक, दे हेल्प इन दिस वे. what percentage of water vapor is there in the atmosphere? See that. What percent of water vapor? If the water vapor of entire water vapor of the atmosphere, I told you, what percent of water vapor is in the atmosphere, total water vapor ki, that is negligible as opposed to if you look at the earth surface. Okay, it is very less. But if you look at the entire moisture located in the found in the atmosphere as the 100, then the troposphere has, मैंने कहा कि around 97% और जो भी है, only troposphere. ठीक है? So these are certain things. My friends, one thing here again, ये जो area आज जो देखा हमने, this is about climatology. I know some of you may haven't studied it properly, so आपको थोड़ा सा problem हो भी सकता है. So I'll do one thing. You study it tomorrow's topic as per your planner. Planner में क्या है? You can see your planner, whatever topic is there tomorrow. In the tomorrow's topic, as per the planner, you have the Earth atmosphere, composition, temperature distribution, structure and temperature. So structure and temperature distribution, I will go for this structure and temperature distribution only tomorrow also. So structure is done here in this one, temperature distribution जाएंगे. So I will do one thing at that time, latitudinal distribution, vertical distribution I just said, how vertically how it is, we have just given. So latitudinal distribution, what is where? I will give you a simple table on the world scale, like I will give you here about the temperature distribution, torrid zone, tropical zone, temperate zone, polar zone, how their differences, what is the basic fundamental things on this. Then I will go for the climatic division world का जो है ना एक model I will give you, which we will discuss later in the coming classes also. ठीक है, tomorrow we will do this. So I hope you will able to do these things. Thermosphere, because ion is there, that's why it form. Okay, in the thermosphere, aurora form due to this. This question which you have asked me here, we have, yes, very nice question it is. You think about this, what is there? We will have a, आप सोचिए इसको क्या है. All of you are requested that the question is asked here in the group. Please see these things. It's so similar, anyone can do, but there is more possibility of even marking a wrong one. You see these things, you think all of us are well aware. Electromagnetic radiation, geothermal energy, gravitational force, plate movement, rotation of the earth, revolution of the earth. Which are the above responsible for the bringing dynamic changes on the surface of the earth? Earth surface में dynamic changes में क्या होगा? Geothermal energy, is it bringing dynamic changes? Is the geothermal energy brings dynamic changes on the earth surface? Plate tectonics, plate movement, revolution of the earth. बताओ मुझे, think. बहुत easy question है यार, come on. Yes, but I will have a discussion on this, how it is, how it impact. Direct or indirect effect of everyone is there, every component is there, but it is saying responsible for bringing dynamic changes on the earth surface. Okay. Don't look at the answer and tell me, okay, don't answer देख के नहीं कहना है, answer is available everywhere. I need the explanation. Anyone? Okay. You think about this, all these points, you have 5, 6 points which is given. Please do see that. Tomorrow I will start from this question itself. I am giving you some time to you, all of you. So my Best wishes to you. Tomorrow we will meet. Tomorrow I will go for temperature distribution and I will show you. This one I will discuss tomorrow with this. You think C? No, don't think. You have to explain the thing, you know. Many of people will think C. Some of you will think about D, isn't it? It's a very, very interesting. All of us were well aware, and believe me, you will have problem in answering this. See you tomorrow. Thank you very much. Any other questions? No question. So thank you very much. See you tomorrow. I'll take up the questions, some of the questions which I haven't taken today deliberately, because there are few things will be covered tomorrow, and whenever we have related topics I'll do. And here also in this case, the topics of in the mains also, whatever you got it, okay, in the last couple of years, questions whatever in climatology, they are very dynamic, and most of the questions are from contemporary theme. So please do prepare accordingly. See you tomorrow. Thank you very much. Keep it up. You are writing good answers. Some of you, all of you are requested to write the answers. You will get the feedback in periodic manner. So thank you very much. Bye bye. Good day. Thank you.